Khan with you. So this is lecture number 21 of Basics of Microwave Propagation. And in this lecture, we will start a new chapter or a new subject. We will learn about refraction because previously we completed the reflection of microwave. So now we are towards refraction. So refraction, if we go with the principle, or you can say the definition of refraction. So this is a microwave radio beam is refracted when it encounters a medium of different density. So this is basically if you correlate it with your normal working. So basically you should be looking into the refraction problem a lot because if you have any problematic link, then mostly reflection is also very important. Everything is important, but refraction is, you can say that it's very dynamic. And like for example, for reflection, we know that there are physical things which are almost always there. I mean, there is some weather impact as well. I mean, because of the value of K changes almost everything, which is the case in refraction also. But in refraction, we are very much concerned about the impurities or different densities within the environment, the path that we have between a microwave, two dishes of a microwave link. Because sometimes if the links are very large enough, there are big links, 60 kilometer, 50 kilometer, then very easily there may be rain in some part of the link. It's not affecting on the whole link. If the rain is on the whole link, then it becomes a normal kind of, I mean, because the medium becomes same. I mean, there's a water medium present in the whole link. But if the rain is in a part of link, like for example, if you take this picture, for example, there's one dish is here and one dish is here. And just assume that this part there's some rain going on in this part. So this rain is changing the wave path. So this kind of issue, the issue that comes because of any abnormality in the link path, and it refracts the light, refracts the wave. So what happens that whenever light wave it travels from one medium and it passes or it enters a new medium, then basically the speed change happens. And this speed change, because when if we just recall some physics, I mean the speed of light is dependent on the medium as well. And in a vacuum, the speed of light is constant, and it's the standard speed of light. It's in the vacuum. But if you take it to any other medium, then the speed of light it slightly changes, and that results in a change of direction. We can see it as well. Like here, if you see, there's a plastic block, and it's an experiment that you can also do at your home with. If you have a small laser, sometimes some child they bought some small laser, or maybe if you have a small laser for any other reason, you have some pointer that you use to point to things. So you can use that, and that pointer you can see from your own eyes. I mean that speed of light, because of the change of speed of light, the direction changes, and we can see it. This experiment, I think, in your childhood, we also did it. Everyone, maybe every child may have did the same. That you put a pen in a cup of water, and the pen changes. I mean, we say, "Oh, see, the pen is broken," and when we take the pen out, it becomes fine again. So here, this should have been the exact direction of pen. I mean, the pen should be here, but this part is in a different medium of this part of pen is in a different medium, and this part of pen is in another medium. So if it has been fully in water, then it should look like this line. It should be fully like this line, and if it is out of water, it should look like this. So there's a change, there's a refraction going on here as well. So if we go to the exact math, refraction of light at the interface between two media of different refractive indices, where N2, this refraction index is larger than this. Normally we assume that this is normal, I mean normal place like where we are sitting, and this is something which has a different index of refraction. Like in this case, for example, assume that this is this plastic block or this is this cup of water. So as soon as the light enters this different medium, this angle, so you see here, this angle is a bit bigger, this angle is a bit smaller. It turns inside. So since the phase velocity is lower in the second medium, when it goes here, the velocity becomes lower, as we say that when it goes to any dense medium or any medium other than air, because air is a normal medium, then if it is going in a dense medium, then it changes. Like if you see from here, when it enters a dense medium, it changes, but when it comes back to normal medium, it changes again. But this change was in the different angle. This change was in a different angle. So this change, if we can say that this change is, if we say that this change is up, if you make an imaginary line here, then if this change is upward, then again make a line here, then this changes downwards. So there's a change in, because here the slow light again becomes higher. It came back to its normal frequency or the normal speed. So the angle of refraction is less than the angle of incidence. So this angle is less than this, because this angle, we can see that this is a high angle. So the ray in the higher index medium is closer to the normal, because if we take this line as a normal, then this is closer to the normal and this is a bit farther to the normal. So this is the principle of refraction. This is the main, I mean, here up till now we are inside the physics only. We are not talking about it in the wave. We will talk further in the coming videos, but just I wanted to give you a kind of background that what is refraction, how it happens, and we will see some reflection related things, and then we will go to our main thing. I hope that this background, because if you see all of my videos in this series, I want you to have a good idea. I mean, if you are working on something, you should have some idea that why it happens, what is the background. So if you don't learn a bit of physics, then you will not know that why this is happening. So my point is that you should have some nice idea that why this happens, so that whenever it happens in front of you, you can easily judge that, okay, this is happening because of this reason. In the coming videos, we will go deep and deep and deep in the realm of microwave. But here I just wanted to give you a background. So see you in my next video. Goodbye.